Today we're going to work through a heat stoichiometry practice problem together. For the following reaction, calcium carbonate yields calcium oxide and carbon dioxide. Delta H is equal to positive 178 kilojoules per mole. And here's our question. How many kilojoules of heat energy is involved in the above reaction if 3 moles of calcium carbonate were to decompose? So first, let's start by underlining the information that has been given. So we have our 3 moles of calcium carbonate is a key piece of information given in this problem. Next, let's identify our unknown that we're trying to solve for. In this case, we want to determine the number of kilojoules of heat energy that would be involved if we had 3 moles of our reactant calcium carbonate. So the way we're going to solve this problem is using heat stoichiometry. We're going to start with our 3 moles of calcium carbonate, and the goal is to convert from moles to kilojoules of heat energy. Now, in order to do this, we're going to have to utilize the information given for our delta H value. So that delta H is our enthalpy, and that represents the heat that's transferred in our reaction. So the sign that I'm seeing in front of my delta H value is positive, which means that this is an endothermic process and that the heat is absorbed on the reactant side. So there's a relationship that we can then make between if I have 1 mole of calcium carbonate, then that means I have 178 kilojoules also that are present. So what I'm going to first do in this railroad track is copy and paste my moles of calcium carbonate down diagonally into the denominator. So we have our 1 mole of calcium carbonate, and again we know that that's equal to 178 kilojoules. So I'm able to put that value on top. Notice that our moles of calcium carbonate will cancel both on top and on bottom, so as we multiply across the top and divide by the bottom of our railroad track, we should be left with the unit kilojoules. So we're going to do 3 times 178, and that will give me a grand total of 534 kilojoules of heat energy that would be involved in this reaction. Be sure to put a box around your final answer, and that's how you would solve number 1 on today's practice worksheet. If you have any questions, feel free to reach out to your chem teacher. We're always happy to help. Have a great day. Bye.